What is the cheapest concert that you could ever go see? No. Because 50 Cent with an opening guest, Nickelback. Because if it's Nickelback, then you didn't pay anything. It's not cheap. They're paying you. And that's what you would have to do for me to see Nickelback. Somebody would have to pay me. I don't like that band. I don't like 50 Cent either, so it doesn't really matter. Still a funny joke. All right. Let's go. Polynomial multiplications, page 53. Oh, I got to plug in my fancy microphone so I can rock the mic, just like 50 Cent does. Okay. Polynomial is a math expression consisting of a combination of coefficients variables and constants. Now, just to remind you of what all these things are. 3x plus 7. The coefficient is the 3. The variable is the x. The constant is the 7. There are some rules about polynomials, but they aren't incredibly important right now, so I'm not going to waste your time with it. For our intents and purposes, if something looks like that, it's a polynomial. Okay? Polynomial comes from the Greek words many numbers. Monomial is a single, please underline single, a single part of, no, not single, that's wrong, or not part, a single item from above. So, 7, monomial, single item. X, monomial, single item. 3x, because the 3 is multiplying the x, that's a single item. Everybody cool? Now, where this gets tricky is here. X, Y, Z. That is still a single item. Why? Because it's connected by multiplication. Please highlight, underline, or do something with that, because that's weird. It doesn't look like a single thing, but it is because it's connected by multiplication. Everybody cool? All right. You all know this already anyway. A binomial is 2 monomials. I don't want to use green. I've already used green. 2 monomials connected by addition. Now, when I say addition, that automatically means subtraction as well, because subtraction doesn't exist. It is adding negative numbers, okay? The only reason we called it subtraction was because people are lazy and don't like writing 3 plus negative 2. So they made up a shortcut of 3 minus 2. It's not really a math thing, okay? So that automatically means subtraction as well. So there. So let's do some examples of it. 7 minus x. Monomial connected by addition. Everybody cool? Do I need to do more examples? No. I'm going to do one more anyway. 3xyz plus 2abc. Still a binomial, because this is a monomial because it's connected by multiplication. Everybody good? Now, remember, there's a lot more to this, but we don't have time to get into all the fancy rules. This is the basic understanding, okay? And lastly, because you are intelligent young people, obviously a trinomial is 3 monomials connected by addition. After that, we just call them polynomials. They don't get special names after that. Everybody good? All right. Last thing, and this isn't really important, but they like you to know it because it makes your work easier to read. Degree of polynomials is the sum, please underline sum, of the exponents. Damn it, I forgot a word there. The greatest sum of the exponents in any one term. So, 2 sum of the exponents, damn it, I forgot another word, of variables. Sorry, everyone, I'm getting ahead of myself. I'm trying to go fast so you can get to work. So in that first example, that blue one, what's the only variable? X. What's its exponent? 1. So the greatest sum of the exponents of variables in any one term. This guy only has one variable. Its exponent is 1. So this guy is degree 1, because that would be a 1. Everybody cool? So what if I had this? 3xy plus 2y. What would that guy's degree be? 2, because this is a 1, this is a 1. They add together, so that is a degree 2 polynomial. This guy only has 1, so this is the greatest sum. Is everybody good? So what if I gave you this? 3x squared y squared z plus 3x cubed. That's a 5th degree, because 2, 2, and 1 is 5. Even though this guy gets a 3 and it's the biggest exponent, these add up to a bigger number. Is everybody good? It is not important at all until your polynomials get huge later in math. Okay, I just want you to have seen it. This is kind of important because polynomials, even in grade 10, can get a little ugly. We usually write them in alphabetical order with the biggest exponent of the first letter first. So, in this question here, what is the alphabetical order? X, Y, Z. So X is first. What's the biggest exponent with X? No, not the degree, this cubed. So if I was going to write this properly, it would be 3x cubed plus 3x squared y squared z, because the first letter with the biggest exponent goes first. Is everybody good? Not super important. Some math teachers would be like, well, you didn't put it in the right order. I'm taking away a half a mark. Am I that math teacher? No. Everybody good? Okay. We don't have time to break out algebra tiles. Cross that out. But we are going to do this with a picture. All of you should have, in grade 9, have done this. What number does that little square represent? 1. What number does that little square represent? -1. What number does this bar represent? X. What number does this bar represent? -x. What number does this big square represent? X squared. What number does this big square represent? Negative x squared. Now, at some point in recent times, somebody realized that using these was really helpful to a few kids in math that were having trouble with the numbers. Then those same people decided that even if you could do math with numbers, they wanted you to know how to do this. And they made it part of the curriculum. And a bunch of kids that can get an A doing everything with numbers, and this is math class, so you should be good with numbers, would lose marks because they didn't understand this, which makes no sense to me. But my bosses say I have to teach it to you, so I teach it to you. All right? You're going to do it 3 times. You're going to do it once on an assignment. You're going to do it once on a test. And then I'm never going to make you do it again, and nor is any other math teacher, because we want you to be able to use numbers. And you'll notice these drawings are only good up to a maximum of squared. Do we ever have numbers bigger, exponents bigger than 2? Yeah, we do. So these are kind of useless. They have one job, and that one job is these are the best way to explain why 7 minus 3 is 10. That's about the best use of these things. They are the best way to show why that equals 10. Otherwise, I don't really have a lot of use for these, but I'm going to show them to you anyway because I'm supposed to. So, this is saying, what does this mathematical sentence say in English? If you're going to read that to me, what would you say? 5 times x plus 3. That's a 1. 5 times x plus 1, right? So x plus 1 would look like this. X plus 1. And then what does it mean to do it 5 times? 1, 2, 3, 4, 5. Easy peasy lemon squeezy, right? That's it. Now, the only other kind of use this has is what we're going to do later. There's your x plus 1, which is a factor. And there's your 1, 2, 3, 4, 5, which is the other factor. Okay? That's it. I'm going to show you that 3 times, 3 different ways. Then I am going to say, know it. And if you don't, you might lose 3 marks over the whole year. More importantly, you need to know this, what this means algebraically. 5x plus 1, you all already know this, means 5 times x plus 5 times 1, which is 5x plus 5, which you can see is the answer right here. 5x's positive 5. Oh, I did 6. 1, 2, 3, 4, 5. There. 5x's right there. Plus 5. Plus 5 right there. Now, some of you will have been taught, depending on your math teacher, this move, which is fine. That's what you're actually doing. Some of your math teachers will have given that a fun name. I don't know what they will have called it, but most of them call it a thing called flying arrows. Have any of you heard that term? Yeah. Go to university and talk to your professors about flying arrows, and they will laugh at you. All right? That's what you're doing, and that's okay. But you should also know the proper name for it. It is the distributive property. And what you are doing is distributing this coefficient into this binomial. You've already seen this in this course when we had this, x, y squared, that 2 distributed to both parts of the base. I will be using the word distribute all through this unit. So you need to know what I mean. What I mean is this. If it helps you to actually draw the arrows, do it. Do not be embarrassed. Okay? Okay. Ta-da, the distributive property. Here it is again. But we're going to write it out the way it always is. A x plus y equals a times x plus a times y. What if this carries on? What if there's a z? Then what's going to be here? A to the z, right? It carries on. It distributes all the way through, right? The coefficient A must multiply by every term in the brackets. Now, the mistake kids make here, don't forget exponents. Meaning all those laws that we just did in exponents still apply now. So, here is the next example of the distributive property. We're going to draw a picture and then we're going to do algebra. This is a factor. This is a factor. The factors go on the outside of the rectangle. How do I draw x? A rectangle. How do I draw 2x minus 4? 2 x's and then 4 little guys. And they are colored in because they're negative. This is x, but it stretches out to make x squared. Then that happens again. X squared. Then what wins? Positive or negative? Negative. And this is my answer. 2x squared minus 4x, because there's negative 4x's there. Of course, if I'm doing this algebraically, that is x times 2x minus x times 4, which is 2x squared minus 4x. And I get the same answer. Why did I remind you about exponents? Because that's x to the 1 and x to the 1. So you have to add them. Everybody can do this in their sleep, right? Do you need to show me this step if you know that that is the answer? Do you actually need to write this out? Or is this enough? You can just do the gray arrows. Do you even need the gray arrows on something that simple? No, because I know that you know how to multiply. Everybody good? Okay. We're going to skip this one because it's the exact same. We're going to turn the page over. We're going to come to here. We're not breaking out algebra tiles, but we are going to show a picture of this. What do these brackets do to x plus 3? What do brackets do? What do brackets do? They make things separate from everybody else, and it holds it together, yes? So this is a factor, which means it's got to go on the outside of my rectangle. X plus 3. This is another factor, so it needs to go out here, x plus 2. And then I just fill in the middle. X squared, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. And this is my answer, which is what? X squared plus 5x plus 6. Now, this is where the next thing that kids screw up on. X plus 3, x plus 2. If this wasn't here, I would have x squared plus 2x, right? If that x wasn't there, I would have 3x plus 6, right? Well, all of you can see that there's some x's and there's some more x's. I like to write this out like this, because now I can see that those are going to add. And I get x squared plus 5x plus 6. Which gives us what has just happened is we have distributed once, we have distributed twice. That gets me, I should have used black, sorry. Distributed twice, that gets me that. Then I distributed a third time and a fourth time, and that got me that. What has happened here is I have done double distribution. I forgot the I. Double distribution. Now, every one of your teachers calls that FOIL. You've all seen this before. FOIL stands for first, outside, inside, last. Which is really, really good for a binomial times a binomial. So we write a binomial x plus 7. We write another binomial x minus 4. And we can do this. First. Outside. The outside pair. Inside, the inside pair. And last, the last two. Wonderful, except aren't there polynomials bigger than binomials? Aren't there? Of course there are. So, when you do FOIL, it only works here. I like to remember it better as extending distribution. So if I got something like this, FOIL doesn't work there, does it? First, oh, okay. Outside, okay. Inside, okay. Last, okay. You're missing something there, right? So I like to remember double distribution because that reminds me that this first guy has to hit all three. Then this second guy has to hit all three. Everybody cool? Now, hopefully your teachers helped you out by giving you a shortcut to FOIL. And that shortcut is very simple. You will notice in this question, what do you know about positive 2 and positive 3 in relation to 5 and 6?
You add them to get 5, multiply.
Add them to get 5, multiply them to get 6. And that will always work when you have this. The trick is x plus a times x plus b. The trick is it's always x squared and then a plus b with an x and then a times b by itself. But that only works when x is alone. So let's look at this. Is x by itself? Does x have a coefficient? No. So it's going to be x squared. And what's negative 1 plus 4? 3x. And what's negative 1 times 4? Negative 4. Now, if we were to do it the long way, x times x, x squared, plus 4x, minus 1x, keep the x's together, minus 4. And then I just add it up. X squared, 4 minus 1 is 3x. 0 minus 4 is negative 4. And I get the same answer. Is everybody good? Spectacular. Practice. Page 56 and 57 is practice. 58 is an assignment. Now stop for a moment. Most of you are going to go straight to the assignment. I know this, you know this. I don't recommend it, but I can't stop you. I want you to pay special attention to B. You're going to screw it up. Pay special attention to, on page 57, you're going to screw up D, and you're going to screw up F if you don't practice it. You will notice that on the actual assignment, there is 2 questions that are like B, D, and F. If you go straight to the assignment and you do J and K wrong, you're going to lose marks. So I recommend you do some practice. I am going to shut up, allow you to work on either polynomial multiplication or your review for exponents and radicals. I'm giving you the rest of this period and all of next period to work. What should be your first priority? The review, because we're marking that today. After you get that done, go back and look at these. By the time you've gone back to look at these, I will have recorded all of the answers on the video. If you go straight to the assignment and you ask me for assistance on page 58, which is the assignment, and let's see your 56 and 57 and they're blank, I'm not going to help you. You're going to need to watch that video tonight. Okay? Go. I will be around to help people in a moment. I'm just writing out all the solutions to 56 and 57. Of course you can. Of course. Yep. All right, ladies and gentlemen, page 56 and 57 have been added to the video. You are working hopefully on your review right now. If everybody's done that review by the beginning of the next block, we'll mark it right away, and then you can just go back to working on polynomial multiplication. You should be able to get it all done before the end of the day and have no homework. Page 58 is the assignment. That is what we will be marking when you walk in the door tomorrow. It says assignment number 2. It is not, but it is an assignment. Okay? I will show you the right answers to 56 and 57 at some point in the last block, so you can make sure you've done it right before you go on to the stuff that is going to cost you marks. Everybody understand? Excellent. And you are working now for 30 minutes, hopefully on your review. Oops. F, E, A, H, C, G, and B. Out of 7. D, E, A, F, where is it? C, D, no, wait. Yeah, D. And 14 consists of a root symbol, index, and a radicand. F, again. Oh, I would also accept B for this. I would accept B as well. Out of 7. When multiplying powers that have the same base, add the exponents. But I'm betting somebody, at least one of you, wrote plus them. I hope you didn't, but one of you did. I know if I walked around, I would find somebody that wrote, you plus them. Who did it? Who did it? To simplify a power of a power, you, of course, multiply the exponents. But I'm betting a bunch of you said you times them. Who did it? Who did it? And this is, of course, 0. So that's out of 3, making the whole first page out of 17. Turn the page over. The proper word for number 4 is reciprocal. But I bet somebody wrote the flip. I bet somebody wrote the opposite, which is wrong because opposite is plus or minus, not flipping a fraction. Root 15, 4 to the 5th. 7, negative 3, negative 3, fourth root of 405, and m squared over n cubed all to the 1/3. I would accept that. But better if you have m to the 2/3 over n. But I will accept both for 7 marks there. 1, 2, 3, 4, 5, 6, 7. Any questions so far? Going once? Madeline. Number 8. Okay, well, 3 cubed is 27, yes? But it needed to be up there. 4 cubed is 64. So what would flip that 3 and the 4 if x was negative 3? Okay. This is big. I don't remember the actual answer. So most of you probably started with 2 and got 4,802. Then you went 2 again and got 2,401. And then you probably went with 7. 7 work? 7. And that got you 343. And then 7 and 49. And then 7 and then 7. So the answer was 2 squared times 7 to the 4th. 2 marks there because it's 2 concepts. So this is 5.1 squared plus 3.5 squared, which is whatever it is. If you wrote that, that's what I care about, because you just use your calculator, find the right answer. But it does say write an expression. And this one is, of course, 4.3 squared plus 9.3 squared. Both of those are worth 1 each. Simplify, lots of ways you could do it, but I, of course, like to take care of inside the brackets first. So that is a to the 3rd, b to the 4th, c to the 6th, all squared over b squared, c to the 5th cubed. Then I take care of the outside exponents. So that got me a to the 6th, b to the 8th, c to the 12th over b to the 6th, c to the 15th. Then I cancel. No a's anywhere else, so it's a to the 6th. 6 on the bottom, all gone. 6 of them are gone, leaving me with b squared. 12 up top, 15 on the bottom, so all the ones up top are gone, leaving me with 3 in the denominator for 2 marks. Because you had to know 2 different concepts there, making that page out of 7, 9, 10, 11, and 2 is 13. Lots of methods you could have done here. I'm betting most of you just punched them into your calculator, but you didn't have to. That's one method you could have used. The way I would have done it would have been this is the cubed root of 40. This is root 30. This is root 64. And this is root 54. Now, cubed root of 40, I know, is between 3 and 4. The rest of those are bigger than that. So I know this is the smallest. So 2 cube root 5 is the least. The biggest one is root 64, which is 4 root 4, then root 54, 3 root 6, then root 30, because I asked you to do greatest to least. If you did them in the other way around, you get yourself a half mark. But there's something important there, right? I want you to understand how you get greatest to least. So that's worth 1. This is, of course, 3 root 5. This is, of course, 2 cube root 5. No, yes. This is 243 is 81. So it is 9 root 3. This is 3 to the 5/4. I would also, of course, accept 3 to the 1.25. This is x to the 4th over y to the 3rd, all to the 1/2, which I would accept. Better x squared over y to the 3/2. Best answer, but I'll accept them both. All these, give yourself 2 for them. 2, 2, 2, 2, 2. And this one is 64 n to the 4th, all to the 1/3. Okay, better 4n to the 4/3. Best. Yeah? Yeah. In a dice rolling game, there's 8 contestants. Now, this question always causes problems. Kids are like, do you mean how many times somebody rolls the dice or how many turns in the game? Obviously, I mean turns in the game because this is a root question, isn't it? If there's 8 people, how many people do you expect to be knocked out of the game in the first round? 1? 8 people are going to roll their dice and only 1 out of 8 is going to roll an odd number? 4 you expect to be knocked out, right? So the first round goes from 8 to 4. That's the first round. How many do you expect to be knocked out in the second round? 2. That's the second round. Now we're down to 2. How many then? That's the third round, and you have your winner. You expect 3 rounds because 8, breaking it down, losing 2 every time, or losing half every time. Now, some kids say, oh, 8 kids are going to roll in the first round, so that's 8 rolls. And then 4 kids are going to roll in the second round, that's 12 rolls. And 2 kids are going to roll there, that's 14 rolls. Some kids say 14. I don't really care. It wasn't until last year that kids started counting actual throws of the dice. Before that, every kid was like, it's 3 rolls. So whatever you wrote. But it's out of 1 because it got confusing. These questions are very sexy in math now. We like to do these to you people because you can have a multiple choice question without showing work. Because you got to recognize where this person screwed up. So Amy's doing her work. Are we happy with the pink line? Why not? That's okay. 1/4 is 0.25. She doesn't like to subtract fractions. Neither do you guys. So whether you like it or not, is her math okay? Yeah. Now what about the pink line? Or what about the green line? Is that okay? No, of course not. Why not? What should she have done here? She could have done, no. Well, she could have done that. She could have reciprocated them. She could have made this 3 to the 0.75 over 3 to the 0.25. She could have done that, but she chose not to. She chose to leave it like it is, and she chose to just apply the exponent law. What exponent law should she apply here? She should be subtracting. What is she doing? Adding. Now where she screwed up is she did minus minus. So she thought, oh yeah, I'm just going to add. But she added a negative number. So there's her mistake. So that's the problem. So the error she made is negative 0.25 plus negative 0.75 should really be negative 0.25 plus 0.75 because minus minus makes a plus, right? Now, let's give the correct solution. So finding a mistake gets you 2. The correct solution is going to get you 2. It's 3 to the, what is this answer? Negative 0.25 plus 0.75. What's the answer? 3 to the 0.5, I will accept that. 3 to the 1/2, I will accept that. Square root of 3, I will accept that. Any of those gets you that 2 marks. So that's 2 and 4 on that page. And 1, 2, 4, 6, 8, 10, 12, and 1 is 13 on that page. So it is 4, and 13 is 17, and 13 is 30, and 17 more is 47. I'll get that number from you tomorrow. Now, as previously promised, there is the first 2 questions from page 56. This has already been recorded, so you can check it later. Make sure you're doing it right. There is the next bunch. Check and make sure you're doing it right. This is the one that most of you are going to screw up, because I bet if I walked around, I will see people that have x squared plus 4. I bet, even though you've seen this before, I bet I see people that have that. Don't make that mistake. Why is it not that? Because this is a base because it's put together by brackets. And squaring a base means you write it twice. Okay? And there's the next page, 57. There's the first answer. There's the second answer. And the rest are highlighted in green. Check your work. You may want to have a good solid look at this one, because you haven't seen that before, and that one, because you haven't seen that before. But you know how to distribute, and you know how to collect like terms. Now, one other thing. Some of you have been taught to collect your like terms this way. On this question, some of you will have been taught to collect your like terms like this. 2y squared. There's the first one. Minus 8y plus 2 minus y cubed plus 4y squared minus y. And then you'll have been taught to do something like this. Okay, y squareds, they get a triangle. Oh, there's another y squared. So there's 6y squared. Y's, oh, they get a circle. So negative 8y and another y is negative 9y. Y cubes, they get a box. Oh, no other boxes. Negative y cubed. And the last thing left over, plus 2. Do I care? No. You like collecting like terms that way? Collect them that way. Some of you like to have pencil crayons or highlighters with you and do this. Y squared, 8y, y cubed, and 2. And you collect your like terms that way. I don't care. I'm not teaching you to collect like terms because you're already supposed to have brought that to grade 10. All right? You collect your like terms however you want. But you will notice the way I write it, when you stack them up, it keeps your like terms together for you. It's automatic. Then you have no concerns. But unlike many, I don't care the method you choose to use. Use what works for you. Okay? Okay. This page, 58, is what we mark at 8:05 tomorrow morning. All right? What happens at 9:25 tomorrow morning? Test. No calculators for the multiple choice. At all. Okay. Everybody good? You got 30 minutes now to work on anything you want. The other option is I move on and do a lesson, which, if I do that a few times, eventually will add up to a whole block. And that would be a block at the end of the semester where we could do something like rewrite tests and things. But it's up to you. Are your brains full up right now? You want to prepare for your test tomorrow? Okay, knock yourselves out. Well, don't really. The paperwork is atrocious. Please do not hurt yourselves here. And I'm just kidding. I would fill out the paperwork anyway, and I would be very concerned about all of you.